Hi, I'm doing waves again. Okay, let me find the question. Okay, because I have a test tomorrow morning. So I'm gonna make it fast. Okay, first question says an organ pipe closed at one end have a length of 0.45 meters and it's the first overtone in a room with temperature is 20 degrees Celsius. Calculate the exact frequency of the sound produced. So velocity equals 331 plus 0.6 times 20, which is 331 plus 0.6 times 20, 343 meters per second. And we know that V equals F lambda, which means 343 equals, we want to find frequency. Actually, no, it doesn't. We can't use this equation, so I mean, we can, but we're gonna make it different. V equals F lambda equals, because it is a closed pipe, so it's 4 L F over N. So it's 4 times 0.45 F times F over 1. So that means F equals 343, 4 divided by 0.45, 190. No, it's just play as first overtone in the room. Okay, first overtone means it's not the fundamental frequency, which means it's at the third harmonic, which means actually it's 3, and times 3. So we're gonna get 571.67 hertz, which equals to 572 hertz, because physics 36 figs. And part B says that explain referencing the direction of the particle motion. Wait, no, that's the wrong thing reading. Sketch the pressure profile of the standing wave inside the pipe. Clearly label the nodes and antinodes. That's the pipe. It's the third harmonic, which means there is the 2 nodes and 2 antinodes. Normally, if it's a displacement distance, it'll look like that. But because it's a pressure, so it look like this. Because pressure, they're different. Okay, so this is an antinode, node, and node. Okay, and for part C, the second augment pipe, which open both ends, is played at fundamental frequency at the exact time. The beat frequency is 3 Hz, and a beat frequency at 3 Hz is heard. Calculate 2 possible lengths of the second open pipe. Okay, so first let's find the 2 frequencies the second one can be. So that means the pipe can, oh my god, just do this. Oh my gosh, what is that? Okay, so the organ pipe, the second organ pipe can be 572 plus or minus 3, which is 375 or 567. Am I tweaking? Yes, I am. 369. Okay, so that means that, where did my question go? That is right. So that means we want to find the length of these. So V equals lambda. V equals to lambda F. And do we know lambda? So the lambda equals 4L over N, which is 4 times 0.145 over 1, it's not 145, 0.45 over 3. That means that, and we have the velocity, which is 343. So it's 343 times 3 over 4 times 0.45. Oh, we want to find the length. We don't have the length. My bad. So that means F, well, V equals F 4FL over 3, which means L equals 3V over 4F, which means that is 3 times 3, 43 over 4 times, it's either 571 plus 3. Let's do that first. So that's 575, which equals to 3 times 3, 43, divided by 4, divided by the answer, which is 0.448 meters. Is that open pipe? Oh, it's an open pipe. So it's not 4, it's a 2. Should be 2. So just have to times 2, so 0. It's not right. That's not right. We did something wrong. Let me see. Is it at this third Is it at this third harmonic? It says fundamental frequency, so it's not 3. I didn't read the question. Oh my gosh. So this should be at 1, which means that it is literally just 343 divided by 2 divided by 575, which is 0.298 meters, or meters, or 343 over 2 times 569, which is 343 divided by 2 divided by 569, which is 0.301 meters. Yep, and that's for the first question. I label it. Question 1. Now let's move on to question 2. Question 2 says, let go. A geological survey team detects seismic waves from an earthquake exactly 15 kilometers away. Longitudinal P wave travels through the bedrock at 6 kilometers per second, while the transverse wave travel at 3.5 kilometers per second. Calculate the exact time delay between the arrival of P waves and the S waves at the survey station. So basically, it's just a time difference. So S waves travel slower, so they must have a longer time. So we just use, because 15 is a distance, divide by 3.5, takes 15, divided by 6, which equals to 1.6979 seconds. Okay, so part B, explain referencing direction of the particle motion why S waves are significantly more likely to cause a tall brick building to collapse than P waves. Excuse me. Okay, Earth, the station's here. P waves are longitudinal. So that means when it comes from the core, it moves like that way and also that way. So that means a building, no, that's such a bad building. A building will move up and move down, which buildings are designed to withstand. But transverse, S waves are transverse, so they go like that way and that way and that way. So the buildings move that way and that way, which makes the S waves more likely to break, cause tall buildings to collapse. And that you just write that, but I'm not gonna write it because it's not that difficult. It's just logic sense. We have to understand that the earthquakes come from the core of the earth and not across the ground. So yeah. Part C says as P waves travel through the bedrock, they encounter a subterranean cave opening that is 12 meters wide. If the frequency of P wave is 450 Hz, then the wave will significantly diffract through the cave opening. We just use V equals F lambda, which means, well, if the P waves are traveling through the bedrock, because it's 6 kilometers per second, so it's 8,000 meters per second. So that's just equal to 450 lambda. This makes lambda equal to 6,000 divided by 450, which equals to 13.33 meters. And that is bigger than 12 meters, which means it will significantly diffract. That's just how waves work. If the wavelength is bigger than the slit, then that means it'll diffract. Not significantly, but it should diffract. So yeah. Oh well, that's that. Hopefully I get good tomorrow. Bye bye.